Hello and welcome to our next example, Newton's law of cooling / warming. So here at the bottom I have Newton's law of cooling. d cap T over dt is equal to K times T minus T sub m, where T is the temperature of the substance that we're dealing with and T sub m is the surrounding temperature. So this is not my example. My example would be different. I would probably just bring some cookies to class and we could all have some cookies. I'd bake some cookies. How I like to eat my cookies. But here we have a coffee break. And so if I enjoy drinking coffee, which I do only with lots of creamer, I like it between 120 degrees Fahrenheit and 140 degrees Fahrenheit. So, a question, once I pour hot water, how long should I wait before I can drink it? And then how much time do I have to drink it? So we have Newton's law of cooling. And Newton's law of cooling is stated in purple. And what we want to find is, okay, when would be the best time I could drink my cup of coffee? And how long should I wait? And so we're going to do a few measurements, all right? And so let's go ahead and start with our first measurement, or not our first measurement, but with our the first part of that is, what is the surrounding temperature? Well, the surrounding temperature in my classroom, the setting is 70 degrees. All right, so K, and then we'll have T minus 70 degrees Fahrenheit. So now we're dealing with everything in degrees Fahrenheit. Of course, you can see that by 120, 140 above. Now, what we're going to do is we're going to solve this differential equation. Well, hopefully you notice this is, again, separation of variables. So we're going to bring everything with a cap T to the left and everything with the lowercase t to the right. So T minus 70 is corresponding to K times dt. We want to integrate both sides. So we integrate both sides. And we're left with natural log of T minus 70 is equal to KT plus C. And now what we want to do is we want to get T by itself. So we're going to put exponentials to both sides. And we're going to get T minus 70 on the left side and C e to the KT on the right. Solve for T. T is equal to, let's go ahead and say, since we're finished now, T of T is equal to 70 plus CE to the KT. What kind of stinks here is we have two constants, but it's not going to be too difficult. We know that, okay, so when I boil my tea, it has to get 180 degrees, but I like to make sure that it's hot. And so at T sub 0, our water that we're going to pour in to start our coffee is going to be 200 degrees Fahrenheit. All right, so we're going to use that initial value to help us solve our C. So at T sub 0, we're equal to 70 plus C e to the K times 0, and that equals 200 degrees Fahrenheit. Now, what we're going to do is we're going to go ahead and solve for C, because we'll have 70 plus C equals 200 degrees. E to the 0 is just 1, and so C is going to equal 130. All right, now we have our equation, and now what we need to do is we need to make sure, just making sure I have everything in its correct space. All right, now what we want to do is we want to go ahead and write out our equation, and we're going to have this. T of T is equal to 70 plus 130 e to the KT. Now, one other thing that we need is we need a certain time measurement. So say we wait 10 minutes, all right? If we wait 10 minutes, we take the measurement of the T again. So here we'll say time 0 is 200 degrees Fahrenheit. And then after 10 minutes, I'm going to check the temperature. And after 10 minutes, I check the temperature. It's 150 degrees Fahrenheit. And so let's go ahead and now plug into our formula. Okay, so hey, this will help me solve for my K value. So I'll just go ahead and do it up here. So we have T of 10. Whoa, put too many parentheses there. T. Oh, no, I didn't. That was a 1. I just don't write well. All right, T of 10 is equal to 70 plus 130 e to the k times 10. And now let's go ahead and solve. So, I'm sorry, equals 150. All right, so let's go ahead and solve. So subtract 70 to both sides, and we're going to get 80. Divide both sides by 130. We're going to e to the 10k is equal to 813. Let's take natural log. 10k is equal to natural log of 8 over 13. And then divide both sides by 10. So k is equal to 1/10 natural log of 8 over 13. Which is going to give me approximately negative 0.04855. All right. And now we actually have our final solution to our differential equation. And we get T of T is equal to 70 plus 130 times e to the negative 0.04855. Right, those 5's a little bit better. T. All right, and now all we need to do is, okay, well, when's the best time to drink? Well, when does the temperature reach 140? Let me box this up in red so we know, okay, this is our equation. So when does our temperature reach, let's just do green. When does our temperature reach 140 and 120? So we're just going to set these two equations up and then just solve. 70 plus 130 e to the negative 0.04855. And then T, so what time is that? And then also we'll do 120 is equal to 70 plus 130. E to negative 0.04855 T. If you want to know, how to solve that, all you do is subtract 70 to both sides. Divide by 130, take natural log. Then divide that by negative 0.04855. So, check that on your own. Again, you could just plug that into your graphing calculator, let it solve. Plug it into Desmos as well. And so what we find is when I plug this in, for the first value, I'm just going to approximate, and it looks like it's going to be around 12.75. Let me zoom in just a little bit more. Yeah, we'll just say 12.75. So 12 minutes and 45 seconds. I'll just go ahead and round to 13 minutes. So we'll start drinking at 13 minutes, and that's where it's going to reach approximately 140 degrees. And then maybe 12 minutes and 45 seconds if you want to be more accurate. And then when we do 120, it's going to be 19.68. And so we'll go ahead and say 20 minutes. We'll reach 120 degrees Fahrenheit. All right, so we want to drink it 13 minutes to 20 minutes after we started putting our coffee. Again, if you do a French press, you can pour it in. You let it sit for 3 to 5 minutes, depending on how strong you want it, and then you pour it out. You got to wait another 8 minutes, and you can start drinking it. All right.